Science is often about puzzles, problems with an assured solution. The real thrill is the ingenuity of solving them, not always finding something new. How could they see the same thing so differently? It's as if their worlds diverged with their interpretations. They built upon a hidden blueprint, a paradigm, governed by unseen rules. But what if that finely tuned clock strikes at an unexpected hour?
So today we're going to discuss the structure of scientific revolution. So bago natin palalimin yung magiging talakayan natin patungkol dito sa scientific revolution, bago natin unawain ano nga ba yung mga aspektong naka-apekto upang mabuo itong scientific revolution, kilalanin muna natin kung sino nga ba yung great mind behind this discovery. And ngayon naman, kilalanin na natin si Thomas Samuel Kuhn. So, isa siyang American historian and philosopher of science na pinakanakilala tigintanyag dahil sa kanyang groundbreaking work, which is the structure of scientific revolution. So, this discovery made him famous, kaya sobrang naging kilala at maingay ang kanyang pangalan. But interestingly, hindi siya nagsimula bilang philosopher. Instead, he was originally trained as a physicist and graduated and earned his doctorate degree or PhD sa Harvard University. So nasa magkaiba talaga siyang field ng science back then. Now, during the years of his teaching of history of science, he came up with this realization that scientific progress as we define like the gradually addition of knowledge from one point to another, so like nagpa-pile up yung information or yung knowledge, is not just a linear accumulation of facts or not just a linear process. So he came up with the idea that during that particular accumulation of facts, you may encounter error, anomaly, or any difficulty that may result to shift in that particular scientific progress. That's why he came up with the idea of the paradigm shift. Okay, then let's have the different phases of sciences, which are the pre-paradigmatic, normal science, followed by crisis, and then the scientific revolution. So mamaya, hihimayin natin kung ano-ano nga ba yung saklaw ng bawat phases na ito at kung ano yung umiiral na sistema sa kanila. So yun yung phase, which is the pre-paradigmatic. So pre means bago, and then the paradigmatic from the paradigm means that is the period when wala pa or hindi pa na-establish yung mga paradigm. So, normal science phase or the normal science period. So, sinusundan niya yung pre-paradigmatic period. So, dito, meron na tayong na-establish na paradigm. So, there exists an actual framework, an actual guideline accepted by majority and accepted by the people. So, during the normal science period, itong mga paradigm na to, it aims not to generate or not to discover something new, but rather to extend the scientific knowledge within that. Okay, so but wait, what really is indeed a paradigm? So, paradigm is not only a theory, but it is a set of practices, assumptions, methods, and standards that is utilized within a scientific community or is practiced by different scientists. So, in simple words, a paradigm is a framework and guideline for them on how to view things scientifically. So, it unites them on a perspective. So, Kuhn also extended his idea on his 1969 postscript na ang pagiging paradigm-based ay isang mature scientific practice. Why? Because it signifies a community's shared foundation. Now, it is conceptualized as a disciplinary matrix. So, this matrix includes exemplars, which concrete, and then agreed upon problem solutions from experience that serve as model. So, nagkakaroon sila ng commonality ng pagkakaugnay-unday in viewing things, and then they are also establishing an agreed upon or napagkakasundoang problem solutions from their different experiences. Then, when the field becomes paradigm-based, kagaya nga ng sinabi natin, researchers operate under common commitment. So, if the researchers operate under common commitment or a common perspective, it will enable an efficient puzzle solving. Dahil mas nag-uugnay-ugnay at nagtutugma-tugma ang kanilang way of practice and way of viewing things, mas magiging mabilis sa kanila ang magiging sistema ng puzzle solving in the scientific context. So, scientists use these shared examples to recognize new situations as similar to old ones, applying established methods without needing explicit, fully articulated rules o pagkakaroon ng priority of paradigms na mapag-uusapan natin mamaya. So, according to Kuhn, normal science is fundamentally puzzle-solving activity rather than being viewed as a side quest for new discoveries. Ang main goal kasi ng normal science ay hindi naman to discover or to generate new discoveries or new knowledge, but rather, or sometimes, expected na kasi yung results. That's why we see a puzzle from Kuhn's perspective. So, according to him, a puzzle is a problem characterized by the assurance of a particular and definite solution. So, unlike a real-life problem or a real-life setting, those problems does not necessarily equate with a definite and particular solution. But hindi kagaya nga doon, under the context of the scientific puzzles, on the other hand, these are granted with a path to resolution. Why? Because a paradigm exists. Given that there is paradigm, there is a set of rules, there is a set of standards, there is also a way on concluding or in coming up with a particular resolution in a particular scientific puzzle. As we move forward to these set of rules, the first one is the explicit scientific laws, concepts, and theories. So, ano nga ba ito? So, these are just stated principles that are practiced and followed by everyone. So, for example, we have Newton's law. We have Newton's law that guides everyone in understanding the dynamics and concept of motion, force, and acceleration. Now, if you're going to view this in the perspective or in a local context, siguro let's start with agriculture. So, in terms of agriculture, there is a law of minimum which states that the yield or growth of crops is not dictated and not limited by the total resources available, but by the scarcest resource which limits its growth. Now, that law alone explains why farmers utilize the use of fertilizers dahil yung natural nutrients nga ay kulang at hindi sumasapat to support the growth. And now, we also have the commitments to preferred types of instrumentation and their legitimate use. So when we say commitments to preferred types of instrumentation and legitimate use, we are pertaining that there are standard instruments or standard methods and standard uses which corresponds with a standard procedure as well. So, merong tama at akmang mga kasangkapan at kagamitan at meron ding akmang panahon kung kailan natin to gagamitin. So these highlights that there are existing and available right instruments and there is a proper way on how and when to utilize them. These tools are accepted because they are scientifically reliable. So para mataya natin na ang isang instrument ay scientifically reliable, it should be grounded on a scientific study for us to prove that it is indeed scientifically reliable. For example, during pandemic, di ba kinailangan natin to undergo various and different kind of tests just to confirm that we are not COVID-19 positive and we are safe. Now, during that time, there exists the standard protocols and the standard tests na pwede natin i-take, which is one of them is the RT-PCR test. But, however, given the context na medyo may kamahalan ng RT-PCR test unlike other tests, may mga tao pa rin nagre-rely on alternative tests na hindi naman verified at hindi naman secured. So with that, nakuha mo man yung result na kailangan at gusto mo, hindi mo naman, or possibly or most likely, hindi mo nakuha yung result na pinaka-standard at pinaka-sigurado ka. Bakit? Kasi hindi natin ni-utilize yung instrument na nakalaan para sa particular context na yon. And then we also have the high level of quasi-metaphysical commitment. So these are shared deeper beliefs that exist in our reality without being constantly stated. So ibig sabihin, ito yung mga umiiral na paniniwala or mga scientifics na paniniwala na matagal nang nag-e-exist at hindi natin kailangan ulit-ulitin or i-reiterate for us just to believe. Kasi ito na yung naka-instill sa atin, alam na natin to. This explains how the world works that is embedded on us naturally. For example, the Philippines has its history and fair share of volcanic eruptions and earthquakes. At alam naman natin na isa sa pangunahing reason nito ay mauugat sa place ng Pilipinas sa ating mundo, which is placed in the Pacific Ring of Fire, which makes our country surrounded by different volcanoes. And then the last one is the fundamental commitments of a scientist. So this just states that the main driving force of a scientist to continue studying is his skill and his passion and his commitment on further elaborating certain concepts. As well, according to Thomas Kuhn, paradigms are more fundamental than set of explicit rules, which simply means that hindi mo man or kahit hindi mo man mataya lahat ng scientific rules or hindi mo man ito makabisado, as long as you are guided and grounded on a paradigm, scientists can still work and collaborate. So for the first one is the difficulty of discovering explicit rules. So Kuhn utilizes the concept of Wittgenstein on the family resemblance, which states that you may or cannot define something only just by having fixed attributes, but you may define them by their overlapping similarities. For example, sa aspeto ng laro, which include chess, basketball, badminton, and sungka. Hindi naman lahat sa kanila ay mayroong same attributes like in terms of technicalities, pero one thing in common nila ay pare-pareho silang may sistema ng players at rules. Ganun din sa context ng agham. Ang pag-iral at pagkakaugnay-ugnay ng mga scientific problems are not rooted on the universal set of rules, but on the idea that they all resemble to one another. For example, sa local context ng mga laro gaya ng patintero, tago-tagoan, luksong baka at tumbang preso, hindi mo naman kailangan ng specific handbook just to identify or determine that they are all kind of games, that they are all type of traditional games. Yun yung hina-highlight dito. Moving on, we have the nature of scientific education, or it highlights that the learning is acquired by two ways. So, scientists don't learn abstract rules at first. Hindi nila ito kinakabisado. Instead, they learn the concept of the said rules through application. Sa paanong paraan? Para mas maunawaan nyo, maaari natin silang ihambing sa mga musician trainings. Hindi ka naman magsisimula by reading musical notes or familiarizing technicalities. Kaya ka nga magte-train dahil you are unfamiliar. So, sa paanong paraan ka or anong way ka pwede magsimula if you are a training musician? You can start by finger or hand exercises that will familiarize you when you are playing notes na. Ganun din sa context ng science. You don't enumerate or you just don't, hindi mo kinakabisado lahat ng concepts and theories all at once. Kasi hindi naman dahil nakakabisado mo sila, it does mean na marunong ka na sa kanila, na alam mo na at naiintindihan mo na ang konsepto nila. The third one is the pattern of debate over rules. So, in the context of natural sciences back then, there is no debates dahil yung paradigm back then was stable and secured. Hindi kailangan ng anumang pagtatalo dahil simple lang, fix ang paradigm. Walang problema, walang kailangang baguhin, walang challenges. The scientists back then just do the work as it is. However, during the revolution period and the pre-paradigm, debates often occur dahil the state of paradigm is not stable and needs further assessment to tell which is which. Ano ang acceptable? Ano ang standard? Ano ang applicable? So, an evident example of this would be during the pandemic, kung saan there are certain safety measures na kailangan nating gawin in order to comply with our safety. So, with that, naging talamak yung diskurso noon kung ano nga ba yung mga safety measures or ano yung standard sa pagtalima dito. The last one would be the existence of small revolutions and diversity of fields. So, first, we have to understand that in light of scientific revolutions and paradigm shifts, science is not monolithic structure. Ibig sabihin, hindi siya iisa, hindi siya stand-alone. Marami siyang sangay at nagsasangay-sangay siya. Therefore, one revolution or shift may or may not contribute to the holistic view of science, but only on its sub-community. Even if they are under the same broad field, the paradigms still have a different applications. With that, a revolution in one sub-community might not shake the entire field, but only that sub-community. But the only that kayo, nakakasunod pa ba kayo sa discussion? So medyo overwhelming and marami nga yung information na tinitake natin. So with that, let's take a quick break muna by doing or answering this short question lang. So, did you know what role do rules play in normal science as puzzle solving? Again, what role do rules play in normal science as puzzle solving? A. They are always explicit statements of scientific law and about scientific concepts. B. They are constantly debated and revised by the scientific community. Letter C. They limit the nature of acceptable solution and its steps, often equating with established viewpoints or preconceptions. Or letter D. They are primarily a product of philosophical analysis rather than scientific practice. So you'll have 5 seconds to guess or to answer. 5, 4, 3, 2, and 1. The right answer is letter C. They limit the nature of the acceptable solutions and its steps, often equating with established viewpoints or preconceptions. So gaya nga ng natalakay natin kanina, rules, both implicit and explicit rules, govern this paradigm.
As we continue with the third phase, which is crisis. Pero bago natin pag-usapan yun, let's have a little glimpse of paradigms again. Paradigms are generally accepted ideas or frameworks that scientists have agreed upon. Ito yung mga bagay na tinanggap natin, mga bagay na hindi na natin kini-question or kini-criticize kasi they are considered generally correct. And ito yung ginagamit nating basis sa pag-resolve ng mga problems natin under a certain umbrella. And for as long as scientists believe na yung mga problema natin can still be resolved by that paradigm, we remain in the normal science. Kagaya ng paniniwala natin na oblate sphere ang shape ng mundo. Kahit pa merong mga nagsasabi na flat daw ang Earth, naniniwala pa rin ng mga scientists na kayang ipaglaban ng paradigm nila na oblate sphere ang mundo. That's why we still remain in the normal science. However, when scientists begin to doubt or lose confidence in the paradigm or in the fact na oblate sphere ang shape ng mundo, we enter a phase called crisis. Pero saan nga ba yun nanggagaling? Ideas like the flat earth is considered an anomaly. An anomaly by definition is an observation that opposes to what is expected of that paradigm. Like I mentioned earlier, anomalies are not really big of a deal to the paradigm for as long as scientists believe that it is solvable by the paradigm in due time. As long as naniniwala sila na mariresolve pa rin yun. Anomalies also often lead us to discoveries or finally defining a recurrent state in nature. Kuhn also emphasizes that discovery is novelty facts, unlike inventions that are artificial. Paano nga ba tayo gumagawa ng discoveries? We have 3 steps in the process. First one is to be aware of the anomaly. I-identify at i-determine kung nasa ng error. Once we're done with that, we can do exploration or a repeat experimentation para malaman natin kung saan pa tayo nagkaroon ng error. And then, through this experimentation, we will have our own observation that we can use for step 3, which is the adjustment of paradigm theory, kung saan makakapag-reflect tayo and magkakaroon tayo ng realization kung saan ba dapat yung palitan nating part or kung dapat nga ba talaga nating palitan yung certain parts of a paradigm. And reminder na sa theory na ito, kailangan na may adjust muna yung theory bago to makonsider na scientific fact. Kahit mapatunayan ko ngayong moment na to na flat yung earth, hanggat hindi na-adjust yung theory, ang nasa paradigm pa rin natin ay oblate sphere siya. Now let's test your understanding of the third phase. The question is, during a period of crisis, what happens to the rules of normal science? A. They become more rigid and strictly enforced. Or B. A sudden deliberate decision by scientists to search for new theories. Or C. They become blurred due to a proliferation of divergent articulations and competing theoretical explanations. Or D. External political and economic pressures for immediate solutions. What do you think? I'll give you 5 seconds. 4, 3, 2, and 1. The correct answer is C. Of course, the theory then becomes a little bit blurry. Pero hindi natin ipipilit na tama talaga yung theory na pinapaniwalaan natin. Rather, we become critical about it and we become open sa kung anumang ideas yung meron at present. And also, we will not try to find solutions immediately in a way that we won't process the thoughts methodically. We now proceed to scientific revolution. Scientific revolution occurs when we realize that a paradigm has to be changed. This happens when an old paradigm is abandoned and a new paradigm is accepted. And that says a lot about paradigm shift, wherein we transfer from an old paradigm to a newer paradigm. And those two paradigms cannot be put side by side to be compared, as those two are actually incompatible. And the proponents of those two paradigms are considered to be inevitably partial about it, not having the right to claim that their paradigm is better than the other, as again, those two cannot be directly compared to each other. And after paradigms shift, how does the world change? Kuhn's idea about this is bold. When a paradigm changes, scientists don't just see old facts in a new way. The facts themselves seem different. He explains this with the duck-rabbit illusion. The drawing does not change, but what you see does. A paradigm shift works the same way. The data and the tools stay the same, but scientists begin to see a new pattern or meaning. The Brenner and Postman experiment shows this too. People were shown playing cards with errors. At first, they didn't notice the mistake and saw it as a normal card, but that's what they expected. Only after repeated exposure did they realize the anomaly. This shows that we need a paradigm to notice something as truly different. But Kuhn points out a key difference. With illusions, you can switch back and forth, just the duck and rabbit illusion from earlier. In science, once a new paradigm takes over, the old way of seeing things usually feels impossible to return to. Literally, there's no turning back with paradigm shifts. For example, once astronomers accepted Copernicus' model, they no longer really saw the sun as rising or setting the same way. Their view of the universe has completely changed the same way the paradigm has shifted. But how do people adjust from this when maybe almost all their life we believe that this certain paradigm is true to us and then suddenly it has to shift? How does it challenge fixed observation? Perception is structured by paradigms. saying that we don't just interpret data differently, we see different data. Also, training is re-education of perception. Scientists are required to learn how to see the world anew under a paradigm. They are required to adapt and not just stay on the knowledge that they have from the past. Also,
for us to better understand this topic, let's have one full circle example through the topic of physical optics, which is a branch of optics that talks about the nature of light as it behaves like a wave. Let's start before Newton. Back then, there wasn't a single agreed upon theory about light. Instead, there were many competing schools with different ideas. Some thought of light as tiny particles, others leaned toward waves, and still, others had ideas rooted from metaphysics and philosophy. The key here is there was a lack of unity. Each school explained the phenomena it was best at explaining, like refraction, reflection, or vision. But there was no framework that encompasses all of that. This was the classic pre-paradigmatic science with scattered facts, random observations, and basically no consensus between everyone. But during the late 1700s to the 18th century, everything changed when Newton entered the scene with his book entitled Optics. His corpuscular theory, the idea that the light consisted of particles, was the first paradigm in optics that most scientists accepted. And during the 18th century, research became more focused. Instead of debating what light was in abstract terms, scientists now tested specific predictions of Newton's model. For example, they looked for evidence of light exerting pressure on solid bodies. This was normal science, when puzzle solving exists with an accepted framework. However, during the early 19th century, it was believed that maybe no paradigm lasts forever, because by then, cracks began to show in Newton's particle theory. Some phenomena like diffraction and polarization didn't fit well with the corpuscular explanation. These anomalies created a sense of unease. The old paradigm was under strain, and scientists began to suspect that something deeper was missing. This was the crisis stage. When Thomas Young entered in the early 1800s, he proposed the wave theory of light. His famous double slit experiment showed interference patterns that could only be explained if light behaved like a wave. At first, this idea was controversial and very scandalous, which shows the resistance to anomalies. But then Augustin Frenzel expanded on Young's work, providing strong mathematical support. Eventually, the community had to make a choice. It's either to stick with Newton's time-honored particle theory or embrace the incompatible wave theory. This was a full scientific revolution, which led to a paradigm shift. After a paradigm shift, we go to the new normal science. In the mid to late 19th century, with the wave theory now dominant, a new era of normal science began. Researchers accepted the paradigm and focused on solving new problems with it. But then, this wave paradigm wasn't the end of the story. James Clerk Maxwell's work on electromagnetism showed that light was not just a wave. It was an electromagnetic wave. And this discovery pushed optics to a new territory, raising questions that the wave theory alone couldn't fully answer. And during the late 1800s, further crisis and revolution continues. The concept of ether, supposedly the medium through which light waves travel, failed under experimental tests like the famous Michelson and Morley experiment. Scientists were actually puzzled. If light was really a wave, how could it exist without a medium? The crisis deepened and multiple competing theories emerged.
It reminds us that science is never finished. It's a dynamic process of questioning, overturning, and rebuilding our understanding of the world.